Right now, you could open a new tab, type a question to an AI, and hit Enter. A few seconds later, an answer appears, and you won't think twice about where it came from. But your question didn't stay on your screen. It left your device, traveled across the country, and landed inside a building the size of a stadium. A room packed with racks of chips that cost more than your car. Machines that, together, drink enough electricity to power a small town. Just to write you a single paragraph. So where does your question actually go? And who owns the machine on the other end? Because the answer is not the company you'd guess. And it changes everything you think you know about who built the cloud, what your questions really cost, and who controls the future of intelligence. Let's start with the company that probably answered more of your AI questions this year than almost any other. And there's a good chance you've never heard its name. In 2017, three commodities traders, Michael Intrater, Brian Venturo, and Brandon McBee, started a company. It was not an AI company. It was a crypto company. They called it Atlantic Crypto. And they did one simple thing. They bought thousands of graphics cards, the kind built for video games, and used them to mine Ethereum. For a while, it worked. Then, in 2018, the crypto market collapsed, and they were left holding a mountain of expensive graphics cards, suddenly worth a fraction of what they'd paid. Most people would have sold. They did the opposite. They started renting the cards out to anyone who needed raw computing power, visual effects studios, researchers, anyone with a problem too big for a normal computer. In its first 3 months, that rental business grew 271%, and that number told them everything. The crypto company was dead. A cloud company was hiding inside it. In 2021, they renamed the whole thing, CoreWeave. Then the world changed. ChatGPT arrived, and suddenly every company on Earth wanted exactly one thing: piles of graphics chips to train and run AI. CoreWeave had just spent years becoming very, very good at exactly that, running graphics chips at massive scale. On March 28, 2025, that company, a former crypto miner from Livingston, New Jersey, went public on the Nasdaq at a valuation of around $23 billion. The year before, it had earned $1.9 billion in revenue. The research firm SemiAnalysis had already coined a name for this strange new species of company: a Neocloud. This wasn't a startup that got lucky. This was a pile of leftover mining hardware that found a second life and turned into one of the most important companies of the AI age. An entirely new kind of company had been born, and the giants never saw it coming. But here's the part that shouldn't make sense, because there's already a company that owns the cloud. You rely on it every single day without knowing. It's called Amazon. When you stream a show, open an app, or buy something online, odds are it's running on Amazon Web Services. AWS is the largest cloud on Earth, and Amazon is not standing still. In 2025, the company spent over $134 billion on infrastructure, nearly $100 billion of that on AWS alone. Now add Microsoft, Google, and Meta. Together, those four companies poured more than $416 billion into building data centers in a single year. That is not a typo. More than the entire economy of many countries in 12 months spent on computers. So how does a former crypto miner survive against that? It doesn't by trying to be bigger. It survives by being narrow. Think of Amazon's cloud as a giant general store. It runs databases, websites, payroll, storage, 10,000 different services for millions of customers. CoreWeave sells one thing: Nvidia chips for AI, wired together for raw speed and nothing else. No legacy systems, no distractions. Imagine you're a startup with a breakthrough AI model and 90 days of funding. You don't want 10,000 services, you want chips now. Go to a hyperscaler and you might wait in line behind a million other customers. Go to a specialist built for exactly this, and you could be training tomorrow. Even Amazon's own CEO admitted that almost all of its new AI capacity sells out the moment it exists, limited by chips and by power. Speed, it turns out, is its own kind of moat. SemiAnalysis, the same firm that named the Neocloud, rates these providers on how well they actually run. CoreWeave is the only cloud company on the planet to earn its highest score. Platinum. And here's the twist almost nobody expects. In 2024, Microsoft alone accounted for 62% of CoreWeave's revenue. The very company you'd assume would crush the upstart was its single biggest customer. And OpenAI, the maker of ChatGPT, later signed deals with CoreWeave that grew past $22 billion. This wasn't David beating Goliath. Goliath was renting from David. The biggest names in computing were quietly paying a company most people had never heard of to run the AI they put their own names on. So how do you build all of this fast? The answer is the part that should make you sit up. Debt. An astonishing amount of it. To buy enough chips, CoreWeave borrowed. In 2024, it carried under $8 billion of debt. A year later, that number had climbed past $21 billion. And what backs those loans is the chips themselves. The Nvidia processors are physically pledged to lenders, locked inside separate shell companies, built so that if a deal goes wrong, only the hardware goes down with it. Graphics cards, turned into collateral. A mortgage on a house made of silicon. Then it gets stranger. Nvidia, the company that makes the chips, invested billions into CoreWeave, and today owns roughly 11% of it. CoreWeave takes that money and spends it buying chips from Nvidia. It has bought around 250,000 GPUs, something like $7.5 billion worth. And Nvidia even promised to buy back any computing power CoreWeave can't sell, a backstop worth $6.3 billion, running all the way to 2032. Money flows out of Nvidia, through CoreWeave, and right back into Nvidia. Critics have a name for it: circular financing. The same dollars, going in a circle, making everyone look bigger. But underneath the chips, the debt, and the deals sits something far more physical, something you cannot borrow your way around: electricity. In 2025, data centers in the United States were already pulling around 62 gigawatts of power. By 2030, that's projected to nearly double, to 134. The true bottleneck in artificial intelligence is no longer the code, or even the chips. It's the grid. The giant transformers these sites need can take 5 years just to arrive. And some operators are now signing deals to build their own nuclear reactors just to keep the machines fed. In a single year, the pipeline of nuclear power signed up to feed data centers nearly doubled, from 25 gigawatts to 45. We are now building power stations to answer your emails. The thing answering your question isn't a website, it's a power plant with a balance sheet. It was never really about who wrote the best software. It was about who could get the chips, the money, and the electricity. First, we call it the cloud. The word sounds soft, weightless, free, as if your question just drifts up into the sky and an answer drifts gently back down. But what if the cloud isn't a cloud at all? What if every question you type is a draw on a machine that someone borrowed billions to build? A machine that drinks enough power to light a city, owned, in part, by a company that, in its current form, didn't even exist a decade ago. In 2017, it was a stack of graphics cards mining a currency that crashed. By 2025, the largest technology companies on Earth were lining up to rent from it. And the whole system now balances on a $400 billion bet wired into a power grid straining to keep up. We built an entire new layer of the world just to answer the questions we type without thinking. So the next time you open that tab and the cursor blinks and you type your question and hit enter, remember what happens next. It doesn't go to Amazon. It travels somewhere far stranger, far larger, and far more fragile than you ever imagined. And most of us never even knew it was there.